So for those of you that don't know, I was not supposed to be emceeing tonight. Our MC was coming from the Department of Defense, where he works in Vicksburg, Mississippi. And he had several flight delays, which caused him to be a little bit late. But I'd like to introduce him. This is Josh Lamont over here to our left. He... It was his idea to get this started a couple of years ago, and it's been going strong ever since. And so we're really thankful to Josh for getting this program going, and we think it's a great way to encourage graduate students and undergraduate students to really think about how they can communicate their research to better reach the public and other folks that they're going to have to talk to later in life, like policymakers, and when they're putting grants in and all these types of things. We think it's a really beneficial experience. So for the rest of the show, we're going to let Josh take over, and I'm sure he's got lots of fun stuff planned, and he might be a little bit harsher of kicking you off the stage after your 90 seconds is up. So.
Thank you, Audrey. So I think we need to give Audrey a big round of applause. Audrey really is a rock star, you know. She's trying to finish up her dissertation, she's already got a job lined up, and she's doing this on top of it, so she's great. So thank you, Audrey. Yeah, so today was a long day for me, and I'm happy to be here, and I'm happy to do this, and hopefully we can have some fun with it. But I think that we missed out on a tradition that we established the first couple of years, and that is doing some type of a crowd-warming exercise to bring everybody together and get your blood flowing. So I want to do that. The first of which, and there are two, and the second is more harder than the first. The first, I just need, we did this the first year too, so I need you to do what I do, and I'm going to direct you, okay? So we're gonna create a storm within the ice lab, okay? So, and we're gonna start on this side, and I'm gonna tell you to do one thing, and you just follow, and we'll move this way, and then I'll come over here and tell you to do it, and you look to the person on your right, and we'll have this storm move in. So work with me here, all right? So we'll start off, and I need you to rub your hands together. Everybody, not just the judges. They already have a hard enough job. All right, so rub your hands and bring it this way. The calm of the storm. So go ahead, give yourselves a hand. Nicely done. You're a great weather front. Okay, so the next one, I want everybody to stand up. Okay, this one is hard. I can't do this, so I don't know how well I'm going to be able to explain it. But I basically need you to take your two hands, and we're gonna call this fingers and thumbs. I need you to take in one hand your pointer finger, in the opposite hand your thumb, and this is going to engage both sides of the brain. Okay, so this is a warm up for the judges, for the contestants. Get your synapses firing on all cylinders. Okay, so what I want you to do is to switch. So your thumb goes to the finger, your finger goes to the thumb. Do it simultaneously. Faster. You want to avoid the guns, and you want to avoid this. Okay, so finger, thumb. Anybody good at this? Yeah, there you go. Useful skill. So next time, party tricks. All right, give yourselves a hand for that one. Good job, guys. All right, so now we're warmed up. And real quick, can I have four volunteers? This is a good opportunity. Yes, sir. 1, 2, 3, and... Okay, Hadi, yes, come on up. All right. You can stay there. You can stay there. Miss, if you would come over and stand by Hadi. All right, so we did trivia in the first half. We're going to do trivia again, okay? Your team Alpha, your team Beta. Got it? All right. Okay, so work together on this, and don't give them any clues, all right? But I need you all to keep score, because I'm not very good at keeping score and asking questions. It's like the finger-thumb thing. I can't do two things at once. All right, so we'll start off here with Team Beta. So I need you to name one of the two physiographic regions that fall within the borders of Delaware. This is tough, isn't it? This isn't fair at all.
Marine science.
That's yours.
What do you mean by physiographic?
Physiographic, like if I were to give you the Atlantic Coastal Plain or the Blue Ridge Mountains, which one would you say? All right, we'll give it to all right, yes. So point one, we'll give it to Team Beta. Good job. All right, so we might, so we'll see how this goes. Team Alpha. My question for you is, what percentage of Delaware's wetlands have been lost since the 1780s? So this is degradation of wetlands since the 1780s. I need an exact percentage.
So it was 25%. She asked the question. Right.
I'll do a similar thing to what I did for them. So it's not quite as nice. If I give you 44% or 54%, and I say, which one is the greater answer?
What do you think?
I mean, that's a hard one, but maybe 50.
54%, yeah. So 54%. Good job, Team Alpha. So 1-1. Okay. All right, let's see if we can get a tiebreaker here with a better moderator here. All right, I'm going to do this, and I'm going to see who's the closest, and this is going to be our tiebreaker, okay? So Delaware is experiencing sea level rise. What percentage of its land area is predicted to be lost by sea level rise by the year 2100? So if you can give me in percent, how much of Delaware's land area is expected to be lost due to sea level rise by the year 2100? You know this one? Well, okay, you've got 3 seconds. 2, 1. All right, Team Alpha, what's your answer?
Go ahead.
45.
45. Sorry, I'm bad at this. Okay, Team Beta.
25%.
25%. Well, you're both very pessimistic. But according to these parameters, we're at between 8 and 11%, which is still very substantial. But that gives Team Beta the win. So let's give them all a hand, and you guys get swag bags for Team Beta. There you go, take one each. And you guys get to select one from this. Yeah, there you go. There you go, that's all, those were your choices. All right. Go ahead and give them a hand once again. All right, so now we're loose, we're ready. I'm sure that Hannah is very ready, so I'm sorry, Hannah. So we're gonna now turn the time over. Hannah Clip from the UD College of Ag and Natural Resources. The time is yours.
Imagine it's early September 2005, and you're a small migratory songbird. You've just spent the past 7 nights flying south over cities, farms, and forests to reach the Gulf Coast of the United States. You're one of millions of birds that breed here in the US and spend the winter in Central America. You plan to feed in forests along the coast before the long, difficult flight over the Gulf of Mexico. But when you arrive, you find the trees completely stripped. No leaves, no berries, no insects. You didn't realize it, but Hurricane Katrina had just struck the Gulf Coast. Not only did Katrina cause over $100 billion of damage and displace hundreds of thousands of people, it also destroyed critical habitat for birds migrating through that region. So your migration is disrupted, but why does that matter? Migratory birds are integral to ecosystems across the United States, but many species are in decline. Catastrophes during migration could spell disaster for vulnerable populations. Right now, we don't really know how hurricanes affect migrating birds, especially on a regional scale. Using weather radar, my research aims to evaluate how bird distributions along the Gulf Coast change across the landscape and over time in response to 20 different hurricanes. Results of my research will help to direct future conservation efforts for migratory birds, especially in the face of global climate change. Thank you.
All right, thank you, Hannah. Before we move on to Stephanie, I want to remind us of one thing that I forgot to say that Audrey told me to tell everyone. So one part of the night that we did not mention yet is that every year we do a crowd favorite. So not only do the judges get to select the winners, but also everyone here. So please be thinking and think back to those who have gone and think about who you'll place your vote for. But after we're done here, you can go back and put your vote in the thing that Josh is holding up there in the back, and we can get a crowd favorite. So with that, we'll turn it over to Stephanie Donor from the College of Earth, Ocean, and Environment.
Thank you. Ooh. Describe yourself in 3 words. And I think right now all of us just had a blank mind, and we're like, no, not this, right? We've been there. You lose every memory you had, every redeeming quality about yourself, every SAT word you ever learned. So if we can't describe ourselves in 3 words or a few words, do you think we could describe a complex dynamic system like the coast in just a few data points? Believe it or not, we have data that represents the coast, and it's about 1 point for every size of a family home. That's not a lot when you think about the coast is changing mile to mile. It responds in different ways. You know, with $320 billion every year coming from the coast and 49% of the population living there, we could do a little better, right? So my lab teamed up with Delaware Sea Grant, and we're trying to find an effective and inexpensive way to get high-resolution data. We want local folks like county officials, park personnel, and safety officials to take data for themselves. They can do this before and after storms, annually and seasonally. So we have a really cool idea. We take commercial level drones and remote controlled kayaks with like off-the-shelf equipment, and we get beach elevation, dune and marsh vegetation, and also surf zone depth. And that accurate data is used in management plans and policy changes. So why are we using a few data points when high resolution is fast, it's easy, and it's empowering local
All right, thank you, Stephanie. So I don't think that our next contestant is here, Samita, so we can skip this one. And And then next up, we have from Delaware Technical Community College, Ed Wolf. Ed, the time is yours.
How many of you have thought about buying a race car, but decided against it because of the drawbacks of having a daily driver? Because there are 2 seasons in Delaware, construction and winter. We all know how hard it is to buy a car that we can use every day. My research is developing magnetobiological fluid, which we can use in an adjustable suspension. So we're able to go to the racetrack and race all day for a track day, and we could go pick up grandma from the hospital, and we could drive her home comfortably. There are actually three main components about MR fluid that we need to worry about. It's sedimentation stability, magnetation stability, and wear and tear on the iron particles in the fluid. My research is trying to show if we can make an inexpensive fluid available for more people. Because right now, it costs about $7,000 to $8,000 for this set of suspension, whereas typical gas shocks will last 100,000 miles. The MR shocks will only last 50,000. So if I'm able to create a low-cost, inexpensive fluid, I can make this technology available to everybody else, except for, not keep it to F1 drivers. So I can go out and buy a Corvette and be comfortable all day long. Thank you.
All right, thank you, Ed. Next up, we have Aaron Betts from the College of Ag and Natural Resources. Aaron, the time is yours.
Lead poisoning is an insidious problem in cities worldwide, especially here in the Northeast. Lead damages the brain. It causes lower IQ. It causes behavioral problems such as ADHD irritability, antisocial behavior. And so the damage that lead is really doing is hard to fully measure. And worst of all, the worst affected victims are children because their minds are still developing. And many of you have heard about the Flint water crisis, that lead was in drinking water, but it's also in it's also in our soils. Through half a century of use, lead was in our gasoline, in our paint, and half a century of it, exhaust from cars and paint chipping off of buildings has blanketed our cities with low to moderate levels of lead. But the problem is more complicated than this because, people get exposed to lead through swallowing dust, through accidental ingestion of dust. And the dangerous portion of lead is the amount that can be digested. And I want to look at what portion of that lead is digestible in our cities.
All right, thank you, Aaron. Next up is Emily Rule from the College of Earth, Ocean, and Environment. Emily.
What do the extinction of the dinosaurs, the Mayflower landing in New England, and your birthday have in common? Horseshoe crabs roamed the coastal regions of our Earth when all of these events occurred. That's right, horseshoe crabs. Those spidery, some might say creepy-looking creatures evolved between 400 and 500 million years ago, making them one of the oldest living organisms on the planet. But those who can look beyond their hard exterior open themselves up to a fascinating story that these prehistoric creatures have to tell us. A story of incredible resilience and survival that you can actually witness firsthand. In the Delaware Bay, millions of adult horseshoe crabs travel from deep waters to spawn on its sandy beaches, leaving behind hundreds of millions of eggs that will fatten exhausted shorebirds as they make lengthy migrations from one end of the earth to the other. Many other eggs will hatch and grow to develop into adult horseshoe crabs, whose blood may be used to test the presence of toxins on important medical equipment that we rely on to keep us healthy. But what will be the fate of developing horseshoe crab eggs in the wake of a changing climate? This question is what my research focuses on. Warming temperatures, lower oxygen levels, and intensifying wave action can all have harmful effects on developing horseshoe crab eggs. Inviable eggs from this keystone species could have effects that cascade outwards from our Delaware Bay ecosystem to a global scale. I believe it is imperative for us to better understand how humans, evolutionary infants compared to horseshoe crabs, could be having an impact on the future of this prehistoric species and our bays. We have already contributed to the horseshoe crab's evolutionary story, and now we must take care not to end it. Thank you.
All right, thank you. Next up is Joshua Sanchez from the College of Agriculture and Natural Resources. The time is yours, Josh.
What do you think of when I say the word arsenic? Perhaps you think of pesticides or rat poison. Maybe you've even heard a story of a historical figure being assassinated in the past using this technique. Well, whatever comes to mind, surely it's not good. Well, just up the 495 in Wilmington, we have a field site along the Christina River with soil arsenic concentrations upwards of 13,000 parts per million. Just to put that into perspective, that is over 650 times the regular background level of arsenic in Delaware soils. Now, this arsenic is relatively stable and in a solid state, but as the climate changes and sea levels rise, this may no longer be the case. Coastal soils in Delaware and throughout the world that were once stable and dry will eventually become flooded and salty. So how exactly will sea level rise affect arsenic-contaminated soils? My research will tackle this question head-on. In the lab, I'm simulating sea level rise on these contaminated soils and measuring just how much arsenic is transformed from its stable solid state into its mobile and toxic liquid state. My research will provide valuable data to policymakers in Delaware and potentially throughout the world so that we could work together to keep this arsenic away from water systems in coastal communities and keep the citizens that live there healthy and safe and arsenic-free. Thank you.
All right, thank you, Josh. Next up from the College of Arts and Sciences, it's Omar Barreda. No, it's not.
No.
All right, it's Nathan. Nathan Castaneda, you're up.
Now, I would like to think that by now, all of us understand the ever-present severity of climate change over the recent decades. Why is this important? Well, it turns out that our contribution of human-caused emissions is threatening our planet's equilibrium, and it's disturbing its natural carbon cycle in a way that makes it increasingly more difficult for us to overcome climate change. With this in mind, I urge you to think about our current solutions for reducing CO2 emissions. Did anyone here immediately think of renewables? How about building a facility that would capture carbon directly from our atmosphere? Now, I know this may sound expensive, and it is. Operating these facilities can be costly and requires a significant amount of energy. However, renewables allow us a unique advantage to implement these facilities both economically and effectively. As it turns out, recent studies have shown that it is in fact possible to operate a renewable-based grid with operating costs similar to what we have now using conventional fuel sources. Furthermore, under this model, when power demand is met, wind turbines are shut off and solar panels lie dormant with the potential energy. Our research focuses on just this. Why not use this potential energy to create a synergy between renewables and carbon capture that allows us to create a grid that both generates clean energy and eliminates CO2 from our atmosphere.
All right, thank you, Nathan. Next up is Kristen Yoshimura from the College of Earth, Ocean, and Environment.
Imagine an environment, one that's barren and desolate, and one where almost no organisms could survive. While it may sound like I'm talking about a desert, what I'm actually describing to you is the bottom of the ocean. And what makes this environment so difficult to live in is that very little food reaches the sea floor. So the organisms that live here, the microbes or the bacteria, have to be able to survive on very little energy. There are areas of the ocean floor, however, where energy-rich methane seeps through the ocean floor and into the ocean. It's like an oasis in a desert. These seeps can support dense communities of microorganisms Instead of lush greenery in the middle of a sandy wasteland, however, these seeps appear as thick orange and white bacterial mats amidst a vast mud landscape. So you may have heard that methane is a potent greenhouse gas. It's about 25 times as powerful as CO2. And there's enough methane that's produced from these methane seeps worldwide to turn our planet into a blazing inferno. So why isn't this happening? Well, it turns out that the microbes at these seeps are able to eat most of the methane before it's released into our atmosphere. But what scientists still aren't sure about is which microbes are able to do this and how they do it. So what I want to do is research this to understand how this is happening. By understanding which microbes are able to do it and how they do it, we can better understand how microbes at seeps are able to lessen the effects of methane release into our environment.
All right, let's give her a hand. Good job, Kristen. Good job. All right, next up we have, next up is Cordy Lynn Goodrich from the College of Earth, Ocean, and Environment. Cordy Lynn, time is yours.
Have you ever been on a road trip and you're in the middle of nowhere on an unfamiliar highway and you are starving? You've been searching for somewhere to eat for an hour and you can find nothing. Then, right as you're about to reach into your console for that old granola bar that you've been saving for a dire situation, you see it. A big exit sign with a whole bunch of fast foods listed on it. Finally, something to eat, right? Believe it or not, this is just another day in the life of the Adelie penguins that live on the West Antarctic Peninsula. Well, minus the granola bars, but their food is very hard to come by. You see, they eat these small shrimp-like crustaceans called krill. Now, these krill are not evenly dispersed in the water. They're found in dense groups or aggregations. So you can have miles of ocean without a single krill, and then in one small area, you'll have a whole group of them. Now, what's remarkable is that the penguins are very good at finding these krill patches. But how? We know we use the signs on the road to find our food, but what signs do the penguins use to find theirs? This is where my research comes in. I use an underwater robot to look at which environmental features, such as currents or temperatures, act as indicators or signs for where the krill are located. If we can figure out what signs the penguins use to find their food, then we can better understand penguin behavior, and we can better understand how the penguins interact with their ecosystem, which is experiencing rapid climate change.
All right, thank you, Cordy Lynn. Lucas is a last-minute cancellation, so we'll skip him and move on to Mark Griesinger from the UD College of Ag and Natural Resources. Mark, the time is yours.
How many glasses of water have you had today? 4? 5? You're supposed to have 8, but I won't judge you if you haven't. You still have time. Now, would you still drink that if you knew it came from a contaminated source? According to the EPA, over 5,000 bodies of water in the US are contaminated from non-point source pollution. Now, most people think of pollution as coming from either a smokestack or the tailpipe of your car. Non-point source pollution happens when something like rain or snowmelt carries things like pesticides and fertilizers on a farm into water. Now, under the Clean Water Act, this is not, non-point source pollution is not regulated, so we have to find another way to deter this. So this is where my research comes in. Using a laboratory experiment, my research will show, well, we will be testing how social pressures affect land management decisions and the resulting pollution. In the experiment, the more you pollute, the more you earn. So we'll be able to measure the trade-off between how green do you want to feel in your group or community, and how much are you willing to, how much do you want to take home in earnings. One of the treatments, we put a flag on your desk that everybody can see, indicating you chose an environmentally friendly technology. If everybody has a flag except for you, are you going to change your decision? Another treatment will have the UD mascot actually shame you for polluting too much. What kind of blue hen are you if the UD mascot doesn't approve of you? So my research will help to show that social pressures are an effective way to assure that the 8 glasses of water you should be drinking every day come from a healthy body of water.
All right. Thank you, Mark. Next up from Delaware State University, we have Isaac Fisher. Isaac, the time is yours.
Thank you. Good evening. What is it? Oh, yeah. Have you ever wondered why plants, they respond differently to different environments? My research is being conducted on common beans or dry beans. They'd be like kidney beans, red beans. And we're taking samples from the same genotype of common bean grown in 2 different locations and then comparing them genomically, but also transcriptomically, and also epigenetics. So they should have the same DNA, they're the same type of plant, but they'll respond differently to the different environments. So this will produce different RNAs that are examined at the transcriptome level. This is important for breeders because as climate change has been mentioned so many times today, it'll be important to combat these changing conditions such as either drought or heavy rainfall, maybe salinity issues, pH changes. So breeders will be able to conduct breeding projects to make for better plants that can be then produce more food. The UN states that by 2050, we need to double the food production in order to feed the growing population. So with changing conditions, it's going to be harder and harder. So the more that we understand about the plant physiology, the better we can respond to those issues by creating better plants. Thank you.
All right. Thank you, Isaac. Next up is going to be Kyle Plush because Erica is not here. So we already got her out. All right, you're ahead of me. So Kyle Plush from the UD College of Art and Sciences. The time is yours.
Imagine the most annoying, fastest growing root you've ever seen. Every time you try to kill it, it always comes back in different spots in the yard. The only way you can get rid of it is by taking out the roots all the way to the very tip. So glioblastoma, or GBM, is the most common and lethal form of brain cancer, and it's deadly for reasons similar to that root. 5-year survival rate for GBM is less than 10%. So of the 12,000 new cases this year, barely 1,000 of them will be alive in 2021. That's 5 years. The reason for this is due to the fact that GBM tumors can reoccur in areas of the brain completely separate from where they originate due to its extensive root structure, or a population of cells called glioma stem cells, GSC. These aren't the kind of stem cells that you hear about that can miraculously heal you. These things are nasty. They have the ability to regrow whole tumors by themselves, they invade brain tissue very rapidly, and often they are left in the brain after surgery. My research uses stem cells isolated from actual patient tumors. We're attempting to identify and understand the reason for their deadliness in brain tissue. Experiments thus far have shown that they definitely move faster than normal tumor cells through brain tissue, and they may even be guiding other tumor cells to follow them as they invade. This complicates removing the tumor if you have cells throughout the brain that you don't know where they are. If we are able to reduce the spread and speed of these deadly roots, then doctors, neurosurgeons, oncologists can kill the weed the first time without remittance of the cancer. Thank you.
All right, thank you, Kyle. Next up from the College of Engineering is Alyssa Givens. Alyssa, the time is yours.
Imagine leading your normal day as a child with cerebral palsy, a neurological disorder that causes permanent motor dysfunction and affects about 500,000 children in the US. Children with non-ambulatory cerebral palsy spend the majority of their day in a mobility chair. We've all heard the phrase, use it or lose it. The same concept applies to your bones. If you don't use them, they become brittle and prone to fractures. Since children with non-ambulatory cerebral palsy don't bear their weight very often, their bone mineral density, which is a measure of bone strength, is dangerously lower than that of the average child. As a result, they're at risk for multiple low-impact fractures that could occur just getting out of bed in the morning or even stepping into a pair of pants. Imagine that kind of start to your day. For 20 years, doctors at AI DuPont Hospital for Children have been trying to combat this phenomenon with a class of drugs called bisphosphonates, which increase bone density and therefore reduce the occurrence of fractures. However, they've noticed that with treatment, some children respond better to treatment than others. My research aims to review exactly why some children's bone density increases more than do others. For example, do children see greater success when they receive medication before puberty, or does one bisphosphonate drug produce greater success than another? Answering these kinds of questions will help ensure that children with cerebral palsy have a greater quality of life, fewer trips to the hospital, and confidence that their days of broken bones are behind them for good. Thank you.
Thank you, Alyssa. All right, our next and final participant is Sierra Schertzinger from the College of Arts and Sciences. Sierra, the time is yours.
Place yourself on your favorite beach. It's gorgeous. Then all of a sudden, it turns blood red. You can't breathe. Children around you cannot breathe, and the whole beach is being evacuated. That's a horrifying thought, right? I mean, that really ties into Tobias's comment about fear. That phenomenon is currently happening across the United States. It's called red tide, a simple single-celled organism, a plant, algae. The thing about red tide, though, is it's toxic. It actually produces a fume, similar to carbon monoxide, odorless and tasteless. However, it causes severe health problems. It attacks your respiratory system. So if you're like me with severe allergies or asthma, it's a serious concern. My research looks at, 1, the actual detection of this plant, 2, monitorization of this plant, and 3, prevention. We do this in 2 ways. 1, field work. We actually hop in a boat, we go out, we take the samples. Then we go in the lab and we test those samples. By understanding how it grows, we can then understand what we need to monitor. By understanding what we need to monitor, we can then build instruments for prevention. Now, this is extremely expensive, and it also is time-consuming. However, I am a big optimist, and I firmly believe that through the science community, through our local community, we will actually be able to come up with methods to do this. Because face it, we all want to protect our beaches and enjoy our favorite beaches for all time. Thank you very much.
All right. Thank you, Sierra. So that concludes the participants. Let's give them a big round of applause. They earned it.
So the moment of decision, but before we get to that, I want to thank a number of people. This is our 3rd event, and in my opinion, I think it's probably the best one we've had. I'm just really impressed with all the participants. And so first of all, I want to thank, first of all, the committee of students who helped organize this. They all did a tremendous job, and especially give thanks to Audrey and Josh for emceeing the program. So let me mention the committee. Audrey Gamble was the chair. The other members are Alicia Broderick. If you're here, just stand up so we can acknowledge you. Thank you, Alicia. Josh Sanchez, whom you heard from. Julia Guimond. Julie here? Yeah, thank you, Julie. And Chris Arbel. So let's give them all. So I also want to thank the judges. We have a number of repeat judges, so thank you, and all the new people. Really pleased that you were able to participate. And I also want to thank again the Denon staff, particularly Beth Chages, for all the hard work that they did to pull this off. And also, again, thank the participants and all of you that attended. We had another great turnout this evening. So now I'm going to turn it over to Josh to announce the winners.
Yes. All right, so we're going to start things off. We're going to do 5th place and work our way up to 1st and our crowd favorites. So can we get a little drum roll? All right, so in 5th place, Sierra Schertzinger. Winner of $50. All right, yeah, come on up here. Dr. Sparks will give you your prize. In 4th place, can you stay up here, Sierra? Yeah. In 4th place, prize of $75 was Emily Rule. Congratulations, Emily. All right. There you go. In 3rd place, with a prize of $150 was Josh Sanchez. Good job, Josh. You know, I feel Josh took over my PhD research, so yeah, I'll get a cut of that. In 2nd place, prize of $250 was Mark Greisinger. Good job, Mark. Apparently, you needed a mustache to do this. It's November. Got it. Okay, we need a drum roll for the first place grand, wait. Let's do the crowd favorite and then we'll do first place, all right? The crowd favorite gets a drum roll too. We can do that. All right. The crowd favorite $50 prize was Kristen Yoshimura. Well done, Kristen. That showed some resolve, huh? She did so good. Okay, now the moment you've all been waiting for. First place, grand prize, $500 goes to Jill Harland. Awesome work, Jill. Great job. All right. You did so well. That's it. Let's give them a big round of applause. They've earned it.